What's up guys, welcome back to the shop. In today's video we're going to be working with some 4140 pre-hard. We're going to be making about 5 different pins for our arbor press that I'm working on. The pins vary in length from like 12 to 14 inches all the way down to like 6. And then this one here is like 1 and 7/16, and I think the thinnest one is 1 and an 1/8. So we have some material I got off McMaster-Carr. It's pre-hardened. You have a couple options when you are looking at making some hardened shafts. I was debating getting some annealed 4140 and hardening it myself, but to be honest, my heat treat setup is just not there yet. So at least going with the pre-hard, it's going to be a little bit more difficult to machine, but we know that the hardness is going to be consistent, which is important because of these pins are probably under a decent amount of load. So we'll go ahead and get this material chucked up in the lathe, and we'll start on one of these pins and go from there. All right, so we got the 4140 pre-hard chucked up. All right, and I'm gonna run the whole bar through the whole spindle. It's just gonna cut down on waste. And so as I make the pins, because they are relatively simple, I'll just keep feeding it out and parting them off. And that should work really well and kind of cut down on me running over to the saw and saving as much of this material as possible. So we're going to be starting out with the thickest pin first. If my memory serves me correct, it's pretty close. We're going to have to take, I don't know, 40 thousandths or something. And this pin doesn't have any crazy features. So we'll take whatever it is to get it down to diameter. We'll part it off. We'll throw a little radius on the end, throw some centers in the end, and we'll call that pin done. All right, we're running 1,000 RPMs. My favorite RPM, I always say that. I just like to run fast. I don't know what that is. We're using a CNMG, the obtuse angle, and we're gonna face the end of this. All right, let's get a center in there next. All right, let's get to it. 1,000 RPM. A little bit of cutting oil on the tip. We'll go ahead and peck it. All right, nice heavy center there. So we're gonna take 73 thousandths off. So we're gonna touch off using our DNMG insert, and then we're just gonna take a pass. I'm gonna feed in 23 thousandths for no particular reason. Looks like we might be cleaning up. All right, let me just see where we're at. 1.482. We got another 60 thousandths, so I'm gonna take 30 more and then we'll remeasure it. Man, this turns nice. Smoky though. Kind of looks like, with a little bit of the flashing, that we have a little bit out around, or a low spot. But we'll take the cut all the way down and then we'll check, see where we're at. Man, that finish is amazing. You can see the heat coming off there with the steam. It's pretty cool. All right, and in this case, oh, here comes the nest. Just gonna break it, I'm gonna back out so I'm not ruining my surface finish because it looks so nice. All right, let me see, do we got a low spot? Well, maybe not. Now I did zero off my tool before I pulled it out. All right, we're looking at, let's see if we got any taper here. 1455. Yeah, looks like we got 1,000ths. 1,000ths taper. Okay. All right, so I need to take off about 30 thousandths. I'm gonna take off 25 more and then see where we're at. A lot of times you're going to get a better surface finish if you take a deeper cut, because the chip will break and it'll look a lot better. Not that this is bad. I want to see if we're running a taper, because I might need to adjust the tailstock if we are. Either that or the center is truly bad. This is the first time using it, so it feels smooth, but it was sold as inoperable, so maybe it has too much run out in the bearings. Now generally it makes more sense for you to drag the tool across the work when you back out. It's a little bit more accurate than bringing it back in, but in case we're right where we need to be for some reason, we'll keep the surface finish good. All right, we do have 3/1000 taper over here. It is a little bit bigger, and I am a little concerned that it is the center, because I believe my memory serves me correct, this lathe cuts pretty straight. So what we're gonna do is I've swapped out to the center I normally use, and we're just gonna take a light cut. We're about 30 over here and 26 over here. So that's about a 4/1000 difference, maybe 3/1000. So we're gonna come back in and we're gonna do a spring cut and see if this is gonna be a little bit more parallel. Before I get too crazy adjusting the tailstock, I wanna just test the center. Other than that, everything looks great. All right, there we go. I'm barely touching. We're just gonna take off 2/1000. We'll see if it cleans up when we get to the bottom. That would be a sad day if that center was bad, but it would also mean that we know this center is good. So if we get down to the other end and we're not cutting, well, that's gonna tell us a lot. And to be honest, it kind of looks like that. Yep, we've stopped cutting. You can kind of see it. See the difference in surface finish here to over here? It's a low spot. I'm gonna start this up and just back my tool back. All right, guys, we went ahead and recut that using this center, and unfortunately, it looks like this center might be better than the other one. It's kind of unfortunate, because I really wanted one of those centers, and they're not really rebuildable, but it is what it is. So currently we're at 425.5, maybe 426 over here, and we're at 425. So we're looking at a half thou taper, which I'm not gonna worry about on this part. It will be completely fine. But before we had about 4/1000 taper. So we improved our taper by about 8-fold, and it's plenty good for this project. We're gonna make the rest of these with this center and we should be good. Surface finish isn't a mirror, but it is consistent. And obviously you're not gonna see this part anyway. So we're really happy with that. We'll get our chamfer and get this guy parted off and move on to the next one. All right, went ahead and flipped my insert around to a clean edge. We'll go ahead and get this guy chamfered. All right, there we go. Tool post is really close to the tailstock quill, but we made it. All right, we're gonna come down here and part this off and chamfer that, and we'll be done with our first pin. All right, so we're using our parting blade. I'm gonna come over here and just touch the end of the pin there. I'm gonna zero, I'm gonna pull out, I'm gonna move over the distance of the tool, which is 120 thousandths. I'm gonna re-zero, and we're gonna be making our length 7 1/4. And then I'm gonna just give a little bit so we can clean it up. I'm gonna make sure I'm not gonna hit on my jaws. We'll step our RPM down, 445. Now I'm gonna leave the tailstock support on until we get down a little bit. And we're gonna power feed this. So here we go. All right, I'm gonna stop. I'm gonna retract my tailstock. Otherwise, it'll get bound up. And I'm leaving some so I can face it and chamfer it. Using some oil. All right, there it is. All right, I'm gonna take this over to the blue lathe and just real quickly face off this end and then chamfer it, and then that pin's done. All right, guys, I went ahead and faced that over in the blue lathe and put a nice chamfer on that. Finished out the length measurement, and we're within a couple thousandth on the length, which is very fine. Tolerance on this is very loose. So we're done with this pin. I'm gonna take it back over to the bench and we'll feed out the next one. All right, we're moving on to the next shaft here, which is gonna be the long one. So there's nothing special with this shaft. There was a cross hole there for a cotter pin, but we're gonna be using a collar, so we don't need that. And then over here, you can see it's worn down. And then on this end, we have a little groove that you could do with parting blade, but actually that's just there for decoration. So what we're gonna do is we're just gonna turn a regular pin, and then we're gonna take it over to the blue lathe, and we're gonna knurl that end, just make it easier to grip. This is just so you can grab it and move it. So we'll get this extended out and faced off, throw a center in it, and turn this down. All right, let's get a center in the end. Run 1,000 RPMs. Come in slow, make sure my quill is locked. We want the center to cut naturally. We don't want it to follow and bounce around. We want it to operate kind of like a boring bar. And there is a little bit of running on this shaft, so I'm trying to be careful, make sure my center actually cuts center and doesn't just bounce around. All right, I'll come in here real slow and just kind of let it drag. All right, that should be good for what we're doing. All right, we're on 1,000 RPMs. The shaft is gonna be turned down to 1 inch, 187 thousandths, or 1 3/16. So we're gonna touch off using our DNMG insert. I'm gonna take 50 thousandths and re-zero that on the DRO. Take 50 thousandths and see where we're at. All right, we got our center recut. We're gonna take 100 thousandths off the diameter, and let's see how we do. There we go. You can tell it wants to take a little more. We're just gonna let that go. All right, we're gonna stop the machine. Our surface finish is good, but our feed rate isn't heavy enough. Just causing our stringy chips. All right, we'll up the feed rate just slightly. All right, we're up to 10 thousandths feed rate from 7. We'll see if that makes a difference. Come back in and touch off. All right, we'll come in here and get this part chamfered. Put a heavy chamfer on here since this pin is going to be manually engaged. Come in quick to minimize chatter. Just make sure my center is tight. I'm going to slow down my feed, 325. Trying to clean up that surface finish. Does it matter? No. All right, there it is. All right, we'll get this guy faced off using our DNMG. Lock our carriage down. See, on these smaller lathes, gotta lock the carriage or it'll slide back. On the bigger ones, it's less of an issue. And then we'll just trim this down. Got a little overzealous there. We overcut that, but we're gonna do a heavy chamfer anyway, so it's not gonna matter. All right, let's get that guy chamfered. There we go, see, no problem at all. All right, we're gonna be doing some knurling on the lathe. Before we do that, let's talk about the tool we're using. So this is a BXA19 Aloris knurling tool. And let me tell you, there are a couple different styles. The style where you press against the side, and this style here where it clamps from the top. This style is far superior to the tool that goes against the side because it creates even tool pressure. It's less stress on the lathe and gives you a better result. Now this Aloris one is really expensive, but it is a really nice quality. And that's what we'll be using. The rollers are gonna be some diamond knurls, so it's gonna give a nice crosshatch pattern. And I believe that they are a medium grade. I did have some straight ones on here a minute ago, but we switched out for these. A couple of notes on the knurling wheels. So we're gonna be transversing the part with the knurl. Now, technically, if you're transversing when you're knurling, they make knurls that are concave, and these are straight cut. And we'd be using the concave ones. However, from experience, I can tell you, at least for me, I've never had an issue transversing with these, and so that's what we'll be using. All right, we're ready to start knurling. We got it positioned over the part. We have our adjustable Allen wrench in here. We're gonna be using lots of cutting fluid. We're gonna be running it at a slow speed and see how we do. I'm gonna come over here to the edge. All right, we're gonna start to tighten this up. All right, we're getting a good cut. I'm going to traverse the part. I'm going to stop, check the knurl. All right, keep going. There's plenty of lubricant, and you don't want to run the knurl all the way off the end. Stop, check the knurl. It's looking good, but I want it deeper. Just gently bring it back. All right, I'm going to give a nice, good bite. I engage the power feed. Make sure there's lots of lube. Stop, take a look. Looks pretty good, but I want to get a little bit more defined. Keep it running. Just going to feed back across the part. Nice and slow. All right. I'm going to give a nice good bite. Then we're going to feed across the part. Lots of lube. And I find that using a gun like this is way better. I've used an acid brush in the past, and you get it up here and it gets dragged into the knurl. You definitely don't want that. Undo the power feed, and we'll blow off. And our knurl looks pretty much perfect. Maybe a little deeper. We're gonna reverse our power feed, and we're gonna feed back the other direction. Give a good grip. We'll feed back out and we'll call it done. There it is, stop the lathe. Gonna loosen our knurl. Bring it over to the side. And we'll air it off. Just gonna take a file card here. All right, I'm really happy with that knurl. It turned out great. All right, we're gonna come in here and part this off and create a little V-groove in the bottom. And a little bit of lubricant. All right, we're gonna use a top-notch insert with a pre-made radius on there to come in there and put a radius on the corner. There we go. So we got a round in the bottom of both of those. Now I am gonna come up here and chamfer this and then chamfer that as well, just slightly. This is just decorative, it serves no function. Just trying to match. Okay, we're matching the other side. And then here we're just gonna kiss it. Kind of break the edge, there it is. All right, so we got a chamfer on both sides. We got our knurl section, we got our relief groove, and then on the bottom of the hole, we have a radius on each side. So this is all visual, and this obviously is just for decoration and grip, and this part is done. All right, we're over here at the bench, just showing you the new shaft next to the old shaft here. So everything turned out really nice. The length of the new shaft is a little longer. That's no problem, and it's also by design. I wanted to have this section be a little thicker, just visually, and that's the part that you grab it from and slide the pin. You'll also notice we don't have a hole here. It's because we're going to be using a locking collar instead of a cotter pin. Other than that, the shaft turned out real nice. Move on to the next one. All right, we're back over at the lathe, and the next shaft we're going to be making is this one here. They keep getting smaller, and we did that intentionally. All right, so we're gonna do what we've been doing. We're gonna face off the end, throw a center drill in it, and bring the live center up to it. I'll bring you back once we get to that point. All right, I've went ahead and made a mark here where we're gonna have our shoulder, and we're gonna do this pin just like we did the last one. We're gonna turn it down, we're gonna stop here, we're gonna have a shoulder that's also turned down, and then we'll knurl that section. All right, 1,000 RPMs. We'll up that feed rate back to the 1 position. Come in here and touch off. All right, and our DRO should be pretty close. We'll take 50 and see where we land. And this black mart, I'm gonna overshoot it a little bit. There is nothing accurate about this at all. It can be accurate within a 1/4 inch. All right, we're gonna take a reading. Our digital says we're at 1 inch forward, 184 thousandths. I'm not expecting much. Within 10 or 20 thousandths is fine, or just roughing. Yep, 1 inch 463. So we're exactly 20 thousandths off, which is fine. We'll rough this in, and then we'll go down to the next spot. So we're gonna take, we'll just take 100. It's 100 thousandths depth of cut. Insert is happy, surface finish is happy. All right, we got our part finished out. Now it's time to get it parted off. All right, we'll bring in the tailstock apart. A little bit of lube. All right, we got the part back over here at the blue lathe, and I'm not gonna show this, I already did when I made this part here, but just wanted to say we're gonna be mimicking this part here. So we're gonna come in here, knurl this with a diamond knurl, and then we'll make our measurements here, face off the front. We'll go ahead and put our groove in there with the radius and then chamfer both ends, and we'll basically end up with this part on the end on both parts so that they match. So we'll meet you over at the bench once we get this finished, and we'll look at the new part compared to the old part. All right, back over at the bench, we got the new pin made. Here's the new pin laying next to the old pin. Couple notes. First off, the overall size, we finished off about 1/1000 undersize. Completely fine for this project. Might even work a little better being a little undersized. In terms of length, we did add some additional length like we did on the other one for our knurled knob. And then this one had a cotter pin that goes in the hole here like this to keep it from sliding over. And we are going to be using a collar instead of a cotter pin. So that collar will go, you know, somewhere right there, and then we should have plenty of room to grab onto that. All right. Other than that, everything else is pretty straightforward. It's going to match the other pin, and we'll move on to the next one. All right, we're ready to make our next pin over here at the lathe. So this is what we're going to be making next. So this pin is basically just a straight shaft, and it has a washer welded on the end of it. And what that's designed to do is just to keep the pin from sliding through. So this one will be relatively simple. We'll start with the same diameter we've been doing on all the other pins. And then when we get to the end, we're just gonna have a shoulder. Now I'm gonna make the shoulder a little bit bigger just so it looks nice and beefy, but there's really no purpose. And then I'm gonna make the length of the shaft a little longer, because when I was disassembling it, it looked like it was about 1/4 inch shy on the end. So yeah, we'll get it turned down, we'll face the front, throw a center in it, and repeat the same process we've been doing. Running 1,000 RPMs, just gonna face off the front. And then we'll throw a center in there. And we'll come in with our Jacobs 18 in and just peck drill that. All right, we got a nice center in there. All right, we'll touch off and take off 100 thousandths. There we go. And we will let this dimension be the final dimension of the step. Looks like we have a decent surface finish, so we'll just take it all the way over. We're just gonna put a nice little witness mark here. That's so we know where we're turning to. And we're gonna take another 100. And after this, we will mic it and see where we're at and adjust our DRO. We have pretty good chip control, so I'm pretty happy about that. And a decent finish. All right, let's mic it, see where we're at. All right, we look 1.321. We're going down to 1.1875. So we'll rough it, we'll get within 30 thousandths, we'll change the feed rate, and we'll take some more serious cuts. I'll bring it back once we get it roughed down. All right guys, we're taking our finished cut, 7 thousandths feed rate, 1,000 RPM. See how we do. Notice how our surface finish is getting worse because we're not taking deep enough of a cut. It'll be fine for what we're doing, but a lot of times you get the best surface finish when you're taking a deep cut, at least with this type of an insert. I'm gonna come up to the shoulder and I'm gonna back out. And let's see how we're doing. It's not bad, all right. You guys are gonna see as I see. 1.189. So we're approximately 1.5 thousandths over size. So I could try to take a 1.5 thousandths pass, but the reality is it's probably too small of a chip. So what I'll do is I'll polish it down another thousandths with some emery cloth, clean up the surface finish, and we should be good to go. Before I do that, I might as well chamfer this while I'm over here. There it is. All right, we went ahead and got this polished out. We're at 1.87 8/10, which is 3/10 within the dimension. Way good enough. We're gonna go ahead and get this parted off and move on to the next step. All right, we're gonna put a baby chamfer on that. Nothing too heavy because this is a registration surface, just to break the edge, and then we'll get it parted. 1,000 RPM, we're just gonna kiss and then pull out. That's it. And we're gonna come in and get this guy parted off. Just gonna use my scale ruler over here, make sure I got clearance on the chuck, and it looks like I'm good. 445 RPMs, power feed, oil, pretty straightforward. We'll part it most of the way through and then take the tailstock out. All right, I'm gonna remove my tailstock support. And here we go. Perfect, worked well. I'm gonna go over to the blue lathe and get this faced, chamfered and cleaned up, and I'll meet you back at the bench. All right guys, here's the new pin next to the old pin. We extended that side by 1/4 inch, and then we extended this boss just for visual sake. All that's doing is acting like this washer. It comes up against the shoulder and keeps it from coming off. It's just a little more elegant than this shaft. Size-wise, we came out, I think it was 3/10 off of the final size. Size doesn't matter in terms of tolerance. If we're within 2 thousandths or so, maybe even 3 or 4, I'm sure we'd be fine. But I'm just trying to make it back to the nominal size that these shafts were. So other than that, shaft turned out real nice. Well, let's go make the last shaft. Well guys, we're on to the last shaft. So this is an interesting one. This is just a cold rolled piece of steel. No work has been done, it's just saw cut. And the purpose of this is to actually catch the backside of this paw when it rests on the back. So it doesn't really need to be a shaft, it's just the way they have it designed. And I can tell that the original shaft, there was damage or it was missing or there was some sort of issue, and then they put this shaft in there in lieu of the original one because this shaft is actually not the right size. So the hole is consistent with all the other pins in that it's 1 inch and 3/16. And this pin, I could measure it, but I'm guessing it's about 1 inch and 1/8 because it's a little sloppy in the hole. So what we're gonna do is we're gonna make this to the right dimension, which is the same dimension we've been making all the pins to, and it's straight, no cuts, no knurls, no nothing. But I am gonna make it long by about 1/2 inch because looking at the design, I'm not quite sure that this is too short or too long, and it's gonna be really easy to face off 500 thousandths or whatever we deem that we need to face off. And if it's long and we have it long, that's fine. It goes into a blind hole and there's a nut that tightens on it and it can be clocked left or right. So again, precision doesn't really matter here. I'm sure this shaft would be 1 inch short and be completely fine. It can't be overly long, but the tolerance here, it's probably easily 3/4 of an inch, if not 1 inch, either direction. So let's get the shaft faced, center drilled, throw a center in there, and then we'll turn this to the same dimension we've been turning all the other ones to. 1,000 RPM. B&MG tool holder that we've been using. Get this guy faced off. All right, that'll work fine. Put our center in the end. This shaft is running quite a bit more true now that we've got to the end of the shaft. In the beginning, there was a warp that's no longer present. We'll switch out for our center. All right, we're gonna touch off and take 100 thousandths. Here we go. All right, we'll take another 100. All right, here's the new shaft next to the old shaft. A couple modifications that we talked about. Made this shaft larger. We went from this size all the way up to 1.1875. We actually undershot the size, 1.873. That's the most deviation we had on the shaft so far. This is the least important shafts of the three. And we're just doing an exercise here, practicing precision. No need to be that precise. That's easily within tolerance if there even was a tolerance. All right, we made it a little bit longer and we chamfered both ends. Other than that, turned out real nice. Well guys, we got these shafts complete. We started over here with the more difficult ones and worked our way all the way to the small ones. We used about 3.5 feet of 4140 pre-hard, and I'm really happy with the way that each of these turned out. We had some nice work over at the green lathe and did some good learning and did some good work as well. So the knurling especially turned out really nice on these two, and I'm really happy with that. A little trick that I tried today that I hadn't tried before was using the paper in the 6 jaw as a soft jaw. Actually worked really well. Everything was concentric and it didn't scratch anything, which is the goal. So overall, I hope you guys enjoyed this video. And if you like, comment, and subscribe, and we'll see you in the next one.